In this video, I will find the oblique asymptote for the graph of this function f of x equals x squared minus 4x plus 3 all over 2x minus 4. An oblique asymptote is what the function looks like when you zoom way out. So you can start to see that here in this graph. And I'm going to switch over to another screen that'll really show this. If I were to zoom out of this graph very far, you could see clearly that this graph is going to start to look like this from left to right. Right? When we zoom in, of course, you've got this other stuff going on, but zooming out, this is the oblique or the slant asymptote, meaning what it starts to look like as you zoom out, as x gets very large in the positive and negative direction. All right, so let's find that. I'm going to zoom back in and see what we're looking at right now. And let's go back to this page. How do you find that oblique asymptote? Well, we have to figure out what is going to happen when this x gets very large. And to get a really good look at that, we're going to divide. We're going to divide x squared minus 4x plus 3 divided by 2x minus 4, because fractions mean division. So 2x minus 4 is going into x squared minus 4x plus 3. Now what we're going to do is say, well, how many times will 2x go into x squared? Or another easier way to think of that is, what do you have to multiply by 2x to get x squared? And the answer is 1/2 x. I'm going to put it over this 4x because we're actually taking both of these terms and we're putting it in here. So I'll say 1/2 x. And now I'm going to multiply 1/2 x times 2x is x squared, and that's what we want, is for these first terms to match up. And now 1/2 x times negative 4 is negative 2x. And you're going to subtract this whole thing. So what I like to do is I like to change the signs in here. So negative, this changes to a positive, because this negative sign outside the parentheses would change everything. Now I can add straight down, and that makes it easy. So x squared minus x squared is just a 0. 4x plus a positive 2x would be negative 2x. Drop down the 3. And now we're saying, what would you have to multiply by 2x to get negative 2x? The answer is negative 1. Negative 1 times 2x is negative 2x. That's what we want. We want these to match up. Negative 1 times negative 4 is positive 4. Again, we're going to subtract this thing, so I'm going to play that trick again where I change the signs and circle it so I remember. That's a reminder to myself that I've changed the signs, meaning that we are subtracting that. This cancels out, negative 2x and positive 2x. Now we have positive 3 and negative 4, so we have a remainder of negative 1. When you have a remainder, just like with regular fractions, this becomes minus, because it's a negative 1, or plus a negative 1. I'll just say minus 1 over this original divisor, 2x minus 4. So this is the same function that we have up here, but it's just rewritten as this quotient and then minus or plus, actually, the remainder over the divisor. As x gets very, very large, this whole thing goes to 0. I'm going to change the color there to show that. This whole thing goes to 0 because you have 1 over a very, very large number, so this gets very small. So this then is the asymptote. I'll just make a note there. The asymptote starts to look like y equals 1/2 x minus 1. All right, now we've got a y-intercept of negative 1. That's about right here. Not about, it's exactly right there. And a slope of 1/2, that's up 1 over 2, up 1 over 2. And we just keep on doing that, up 1 over 2. And now we can draw our asymptote. That's not part of the graph. That's why I'll use a dashed line to just show it's just what the red, or the real function, is following as you zoom out farther and farther. And we saw that when we zoomed out. And that's the way you find an oblique asymptote. I hope that helps.